Today I want to talk about numbering systems that you're going to run across in your computer classes. The first one is the one you're all familiar with. It is the decimal numbering system. It's also called the base 10. Base 10. And this system uses the characters 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 to represent numbers. Now, it's called base 10 because it uses 10 characters to represent numbers. And it also is called base 10 because each place value of the number is a power of 10. The second numbering system, and I'm sure you're all familiar with place values, so that was kind of crooked. So let me fix that really quick. Okay. So the place values, right? Let's make a number with 4 place values. The place values, it's base 10, so the place values are powers of 10. 10 to the 0, 10 to the 1, 10 squared, and 10 cubed. And what are these numbers? Well, this 10 to the 0, anything to the 0 is 1. Anything to the 1 is itself, so 10. And this is 100. And this is 1000. Right? So this is the base 10 numbering system. Now, one thing that I want you to do is to kind of get it out of your head that these are numbers, right? So these are all the numbers you're familiar with. You're like, okay, these are numbers and everything else is not numbers. Well, not exactly. I want you to think that these are symbols that are used to represent numbers when they are put in specific place values. That's the idea that I want. And you can represent numbers using other symbols and other place values. And that leads us to our second numbering system, which is called the binary numbering system. Binary. It's also called the base 2. And it uses 2 characters to represent numbers, 0 and 1. And for the purpose of your computer classes, I want you to write binary numbers using 8 place values all the time. This is called an octet, or it's called full octal binary. So, and it's 8 place values, 1, 2, 3, 4, 5, 6, 7, 8. And these place values are powers of 2. And they're laid out in the same way because it's a base 2 numbering system. They're laid out the same way. So this is 2 to the 0. This is 2 to the 1, 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th, and 2 to the 7th. And what do these, that was kind of a short 7 there. There we go. And so what do these represent? Well, this is 1, this is 2, 4, 8, 16, 32, 64, and 128. Those are the place values. So a 1 here is equal to 128, all the way down to a 1 here being equal to 1. So that's the second numbering system, and you can simply use the characters 0 and 1 to represent every number out there, pretty much. The third numbering system that I want to talk about is called hexadecimal. Hexadecimal, or base 16. Base 16. And hexadecimal uses the characters 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F to represent numbers. And these numbers are also, or these symbols are also plugged into place values. And again, they're laid out as it's base 16, so they're all powered. All the place values are powers of 16. 16 to the 0, 16 to the 1, 16 squared, 16 cubed. So what is this? Well, this is 1, this is 16. 16 squared, 256, and 16 cubed is 4,096. Those are these place values. And that is the difference between, you can represent any number out there by plugging these symbols right here into these place values, and you can convert numbers between all three of these numbering systems: decimal, binary, and hexadecimal. Now, if this all made sense to you, then go ahead and stop this video, because I'm gonna talk about a fourth numbering system, which is a base 20 numbering system, to illustrate my point that these are just symbols that represent numbers, and you can make any number out there using symbols and place values. So check this out. There is a base 20 numbering system out there, and it is the Mayan numbering system. Mayan numbering system. And the Mayans had a base 20 numbering system. Base 20. And they used two characters. They used a dot. I guess that's an okay dot. I feel like I need a darker dot. There we go. And they used a dash. They used a dot and a dash. Now, how did they put those in place values? Well, let's do 4 place values, okay? And it's base 20. So how do you represent these numbers? Well, how do you lay out these place values? Well, exactly the same way. I meant to put a 2 there. Here, let me erase that. There we go. So this is 20 to the 0. This is 20 to the 1. 20 squared. 20 cubed. So what is this? Well, this is 1. This is 20. What's 20 squared? 400. And what's 20 cubed? Well, 400 times 20 is 8,000. 8,000. So how did they make numbers? Well, this actually represents 1, and this represents 5. So if you want to make the number 1, you put a dot here. If you want to make the number 21, you put a dot here. What if you want to make the number 101? Or, well, let's make it easier before we go that high. How do you make the number 2? Well, you put 2 dots. So you put a dot here and a dot here. The number 3 is 3 dots. The number 4 is 4 dots. And the number 5, you probably can catch on to the pattern here. The number 5 is a bar. It's simply just a bar, just like that. The number 10 is that. The number 15 is 3 bars. And then 16, 17, 18, 19. That's the number 19. And then if you want to make the number 20, you simply put 1 dot in the 20 place value right here. And that's the number 20. So if you want to make the number 100, how many 20s do you need? Well, you need 5 20s. So you put a bar here. That's the number 100. The number 101 is a bar here and a dot here. It's 101. That's how the Mayans represented numbers using a base 20 numbering system. Combinations of dots and dashes in all these place values. And that, to me, is a very brilliant way to represent very large numbers using kind of the minimum number of symbols. Completely brilliant. I mean, who knows how many thousands and thousands of years it took them to distill such a complex numbering system into such a simple way to represent it. That's completely brilliant. And that's Mayan. So you can represent. So we talked in this video about base 10, which is decimal, which is what you're all familiar with. It uses these symbols to represent numbers. We talked about binary, which uses base 2, which uses these two symbols to represent numbers. And then we talked about hexadecimal, or base 16, which uses these 16 symbols to represent numbers. Now, when you go take your tests, you can use scratch paper, blank scratch paper. And on your scratch paper, I think it would be helpful for you to lay this out, right? And write hexadecimal base 16, because, you know, these numbering systems are not intuitive. You're used to decimal, so decimal's probably intuitive for you by now. But these are probably not intuitive, so it's good to just kind of lay them out, right? And then it's helpful to write kind of the decimal value of these letters here so that you have a frame of reference. So it might be helpful to write 10 here, 11 here, 12, 13, 14, and 15. So let's do one sample number. Let's take the number 255. How do you write it? Well, in decimal, it's easy. You all know how to do that. It's 255. And what does this number mean? Well, it's 2 100s, it's 5 10s, and 5 1s, right? So how do you represent that in binary? Well, how many 128s do you need? Well, I don't know, but you definitely need one. Do you need two 128s? Well, no, because that's 256. So you definitely need one of those. You need a 64, you need a 32, you need a 16, you need an 8, you need a 4, a 2, and a 1. And if you add 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, it equals 255. So how do you represent 255 in hexadecimal? Well, how many 16s do you need? Well, I don't know. Well, let's see. This is 256, so that's too much. So we don't need any of those. But man, you know what? Like this we're pretty close here. Let's start out. What is F16s? What is F16s? Well, it's 15 times 16. What is 15 times 16? Well, it's 240. 240. Wait, we have to represent 255. So we have 15 left, so we need an F here. So we need F16s and we need F1s, or we need 15 times 16 plus 15 times 1 to represent 255. And so that's the number 255 in decimal, binary, and hexadecimal. I'm going to leave Mayan out because I just put this in as kind of a cool sidebar to represent my point, which is that these right here are symbols used to represent numbers, and you can use any symbols to represent numbers. Hope you found this video useful. This is the first video in a series of videos about numbering systems that you commonly encounter in your computer classes. So stay tuned for the next video. We're going to get into conversions, how to convert from decimal to binary and back and forth.